All right, we're going to be finishing off Unit 2 with this notes on the 2.9 and the 2.10 study guide today. There are only study guides and not checkups for these sections because it's really just kind of an introduction to some final vocabulary on triangles. So here we go. If you're doing this in your math notebook, please title it Notes 2.9 to 10 Study Guide. All right, the first vocabulary word we're looking at here is median of a triangle. This is a line or segment that passes through a vertex and bisects the opposite side. So let's go ahead and draw a couple examples over here. So well, first of all, let's go ahead and put a dot on what we think might be the midpoint of the opposite side. So for example, if I'm looking at vertex A, what would be the midpoint of the opposite side? I don't know, maybe around right there. If I'm looking at B, what would be the midpoint of the opposite side? Maybe there. And if I'm looking at C, maybe that's the half point. Now there is a way to do this with a compass where we actually use a tool to see exactly where the middle is. But here, for the purposes of our sketching, we're just going to hand draw the best we can. So for example, point A to the midpoint would go like that. The vertex B to the midpoint, maybe like that. And vertex C to the midpoint, something like that. Let's go do the same thing over on the other one. Again, if I had to guess where that middle is, maybe somewhere like that. Where's the middle here? Where's the middle here? And then we go ahead and draw our lines from vertex A to the midpoint, from vertex C to the midpoint, and from vertex B to the midpoint. Finally, let's go do the last one. Again, let's go sketch where we think those middles are, maybe about right here, maybe about right here, maybe about right here. And so from vertex A to that midpoint, from vertex B, and from vertex C, something like that. Those little lines are all called the medians of your triangles. There are 3 medians in every triangle. Okay, let's go look at this next definition. Next definition is a centroid. What is a centroid? It is this center point that we just saw on all 3 triangles where those medians intersected. So we could say it is the point where a triangle's 3 medians intersect, and it's the only point that is shared by the triangle's 3 medians. So this is the definition of centroid, our second word of vocabulary for this section. Again, feel free to pause this video if you're handwriting this in your notebook and you need more time on writing these out. If you're doing it on Kami or in the big book with me, then you are able to keep up. So use this image to answer the following question. How does the triangle above show that the medians bisect the sides of a triangle? So here we are with this word medians, and here's my median, here's my median, and here's my median. How do we know it bisects? Well, do you guys see these numbers over here? How this is a 16 and this is a 16, and how this is a 19 and this is a 19, and then how this is a 21 and this is a 21? Well, that's how we know. We would say that the length label for each side shows the median divides this side into 2 segments. Which is the definition of bisect, 2 equal segments. So those length labels for each side shows us that. All right, when you're ready, we're coming on down here to our third definition, an altitude of a triangle. There's 4 total definitions in these notes. So we just talked about medians, vertex to the midpoint. Now we're going to talk about altitudes altitudes are still drawn from the vertex, but they are drawing a line that is perpendicular to the line containing the opposite side. Remember that perpendicular means that we're forming a 90 degree with that line. So this time when I go to draw in these line segments, it's not going to be straight to the midpoint. It's literally going to be straight down, forming a little 90 degree angle. That's what forms an altitude. So this time we're going to notice that it's not going to create a centroid right in the middle of the triangle. This time in drawing, this time in drawing it straight down, and forming these right angles, it is going to create an off-centered point of intersection. So doing this final one straight down to form the 90, you're going to notice that this center is not a centroid anymore. It's off center. Okay, let's go draw it over here on this one. So A is going to go straight down, forming the 90. And then B is going to go straight down. Sorry, that was, oh, here we go. B, straight down, forming the 90. And then finally C, drawing C straight down and forming that 90. Notice how off-center that is. Okay, now this one out here is different because it is an obtuse triangle, where it has an angle that's greater than 90 degrees within it. When there is an obtuse triangle, one of your altitudes, like if I go and I'm talking about point A right here, and I'm trying to draw from the vertex to a 90, you've got to give yourself some kind of an extension line here, because this line from A straight down is actually going to land outside of the triangle. And then if I go draw B straight down, that one is going to be inside. Oops, I keep forgetting to use my little pen. It's not a very good one. Let's go draw a different altitude like this. Oh my gosh, I keep accidentally grabbing the wrong tool. Hang on. There we go. So that altitude is inside, but go check out C. C also needs an extension because C is also going to be drawn outside. Straight down, forming the 90. So what happens differently on an obtuse is that the altitudes can be outside the triangle, but medians are always inside. Okay, so altitudes can be outside. Now, we're noticing that these points of intersection are going to be all different spots. I don't know, something like that, where this is your point of intersection. Notice that it's not central inside the triangle. So what is this thing called if it's not a centroid? This is called your orthocenter. And the orthocenter is the point where a triangle's three altitudes touch. This is the only point shared by a triangle's three altitudes. So an orthocenter is the point of intersection of the altitudes. A centroid is the point of intersection of your medians. So we've got 4 new vocabulary words we have to become familiar with before this apex quiz. All right, using this image, go ahead and label. So here we go, labeling the orthocenter. And it's asking us, how does the triangle above show us that the altitudes are perpendicular to the sides of the triangle? And so we could say the angles formed where each altitude meets a side is marked with a right angle. Symbol. That little square, right? And so perpendicular segments meet at right angles. And that's how we know. Okay, last thing we're going to do is over here on this little table, kind of comparing the two between median and altitude. And so we're going to look at what is the same, and we're going to look at what is the difference between each one. So what is the same right here in the center between a median and altitude is that they both are lines that connect a vertex to an opposite side. But something that's very different is that the median bisects a side. It does not have to be perpendicular. It is always inside the triangle, and it intersects at the centroid. Now, an altitude, opposite of that, an altitude does not bisect a side. It must be perpendicular. It is outside of the triangle sometimes, and it intersects at an orthocenter, not the centroid. So here's our differences and our similarity between the two. Take a minute to copy down this table or fill in your blanks if you're working with Cami or the big book. All right, now we're going to go on to section 210. And 210 is just a couple pages with a couple new vocabularies on bisectors and mid-segments. All right, so take a minute to continue your notes here. And let's start with our first vocabulary, angle bisector of a triangle. This is a segment that divides an angle of a triangle into 2 equal parts. You can also say congruent there if you prefer. So an angle bisector of a triangle, it's a segment that divides an angle into 2 equal parts. So go ahead and just sketch this out. There's one, there's another. An angle bisector is going to cut that right into 2 equal parts. So this is my angle bisector. What do you think? Okay, the in-center of a triangle is the point where a triangle's 3 angle bisectors intersect. So the point where a triangle's 3 bisectors intersect, and it's the only point shared. This is your in-center of a triangle. Okay, so this over here is an angle bisector in terms of two rays, but let's look at these in terms of this triangle now. So notice that you can see that this is 37 and this is 37. That angle has been bisected. Notice here that you can see this is the same and they've been bisected. And finally, likewise here. So label the incenter. Okay. Label the incenter. How does the triangle above show that angles bisect each angle in a triangle? And this can be in your own words, please, or here's a possible response. And the angle formed, the label in each angle of the triangle shows the two angles formed by the angle bisector have the same measure. Okay. Finally, I hope this word's not brand new for you, but a perpendicular bisector, but now we're going to be talking about it as far as a triangle goes. Perpendicular bisector is a perpendicular segment that divides a given side of a triangle. So this is here's circumcenter of a triangle, known as the point where the triangle's three perpendicular bisectors intersect, and it's the only point shared by the three perpendicular bisectors. Okay, label the circumcenter. And how does the triangle above show that the perpendicular bisectors bisect each side? And so we're going to say, see how this is a 5 and this is a 5, and this is an 8 and this is an 8, and this is a 9 and this is a 9. So the labels on the triangle sides show that the two segments formed by a perpendicular bisector have the same length. Okay. And then finally, how does the triangle above show that the perpendicular bisectors are perpendicular to the sides? And so again, the angle formed has a mark, like that little mark, with a right angle symbol. And we know that perpendicular segments meet at right angles. And so finally, let's look at a little diagram here between an angle bisector and a perpendicular bisector. Both of them bisect part of a triangle, but an angle bisector bisects the angles, and it intersects at an incenter, whereas a perpendicular bisector bisects sides that intersect at the circumcenter. And these form right angles. Right angles are formed. Okay, so within this entire section, the 2-9, we had to understand median, and its center is the centroid. We had to understand altitude, right? That forms that 90-degree angle, and its orthocenter. And then in this section 210, we just got angle bisector, and we found that it's got an incenter. And then we got a perpendicular bisector, and we found that that has a circumcenter. So these words go together, and we have to be familiar with them, okay? This guy right here, this guy right here, these guys, and these guys. How'd you do?